Let me turn it over to Paige. She was highly recommended to me. She's with IBM, and she's a product manager there over many different technologies. So she's going to talk to us today about how these technologies can come together in IBM's view and what she's learned from her research there to enable IoT solutions. So with that, I'll turn it over to you, Paige.
Thank you, everyone, for joining. I wish I could be there in person. When I was coming up with this topic, I think I was a little ambitious, and I don't think that's wrong. I just think that it's a lot of information to cover in a relatively short amount of time, considering the complexity of all of these different technologies. And when you think about edge computing, 5G, blockchain, some might say they're buzzwords, some might say they're already in full steam. And so I think it just depends on who you ask and their experience in the industry. As I was saying, these all are very complicated topics. I tried throughout this presentation to go through and simplify the definition for the sake of this conversation. So while it may not be the dictionary definition of what each of these are, it really is going to just cover what we're going to talk about, how we're going to talk about them in the context of this presentation. So moving on, a little bit about me. I am a TCU alum, class of 2017. I'm not sure if there's any other frogs in the room or online, but had to give a shout out just in case. As I mentioned, currently living in Dallas, have been here since college, well, I guess Fort Worth, but then moved to Dallas after college and started at IBM. I studied strategic communication in school and minored in business, so didn't necessarily see myself ending up at IBM, but I let the cards fall, and it actually has been a really great experience because I've been able to tie in my interest in technology with some of my strategic communication background. And initially I started off in sales because with my focus in advertising, I thought, well, I like selling and I like the concept of selling things, but I want to sell something that people really need and that businesses need. And that ended up being technology. And so although it wasn't cut out for me to be a doctor or something in the health field, I really wanted to feel like I was helping people with whatever I was doing. So the next best thing was to work for a company that's creating technology that can help businesses and society as a whole. So kind of going into why blockchain, that's where I started out. I always like to say that I have trust issues. And I think that in all seriousness, I felt that whether it was in advertising or in other areas of business, there was a lot of uncertainty and a lack of visibility into the processes and the transactions that take place. And so by studying blockchain and being able to really sell a technology that instills trust in the foundation of business, that was where I really found my passion and my interest. And so that's how my career started out. Spent about a year doing that, talking to businesses of all sizes, whether startups or larger corporations, and really helping them go through the design thinking process, figure out what it is, what their use case is, and whether blockchain is really necessary, because sometimes there was blockchain being done for blockchain's sake and not because it was actually the right solution for the problem. Once I was able to have that client interaction, I decided I wanted to get closer to the product and go more into the program management, digital engagement side of things, and work on the consumability of the offering from a digital perspective. So did that for about 9 months, and then most recently moved over into the telco 5G edge product management space. So I think it's an interesting way to tie it all together with IoT, and that's what I'm hoping to do today, is kind of connect the dots on what I've learned, what I'm still learning. So I don't have an extremely technical background, but I'm trying to grow that, and really interested to hear everyone's thoughts and the way that you guys see these technologies working together today. So as far as an agenda goes, we'll start off with some predictions, because if we're talking about the future of IoT, we have to look at what others, analysts more specifically, are predicting is going to happen. And then 3 or 4 years from now, we can look back at this and see did that really come true? Was that an over-exaggeration, or was it an underestimation? Then we'll talk about first AI and IoT, followed by Edge, 5G, make this a little bit more tangible by talking about some of the work that IBM is doing with Verizon in this space to tie these technologies together. And then last but not least, explain a little bit about where blockchain fits into this picture and connect the dots, because I will admit I'm going to cover a lot of different subject areas. And so I think we'll all need to kind of debrief and revisit the big picture, if you will. So starting off with predictions, the first is really around the number of IoT devices. According to Statista, they're expecting it to more than double to 21.5 billion in the next 5 years. And more specifically from an industry perspective, in the industrial market, or sector rather, they're expecting IoT connections to have 107% growth rate just from, I guess, what's now last year, 2020 to 2025, reaching 36.8 billion. And want to differentiate between these two statistics. One is about devices and the other is about connections. So that's kind of where the numbers differ. And last but not least, according to IDC, the IoT devices are expected to create nearly 80 zettabytes of data in 2025. So we'll see if we get there. We'll see if we surpass that. But these are just some predictions to set the stage as to why, and I'm sure many of you know, since you're in this group, why IoT is so important. So to net it all down, this was something that I tried to explain in the meeting description, and hopefully it was clear. But when it comes down to it, the more devices there are, the more data there is out in the universe. And that data needs to be gathered, processed, and analyzed, all of which is made possible and is optimized by 5G, Edge, and AI. I'll explain in the following slides how each one comes into play, but that's kind of the first piece of the puzzle. The second piece of the puzzle is that this data that's coming from all these devices via 5G at the edge ends up being more vulnerable because it's coming from so many different places and it's out in the universe being processed at the site, most often at the site of the device. So that does increase vulnerability, but there's technology like blockchain that can instill trust and verification in that data and therefore make it more valuable. So those are kind of the two spheres that we'll be talking about today and how they intersect. But wanted to set the stage with that statement. So first and foremost, AI and IoT. This is really the obvious statement up top, is that the enterprises are using this IoT device data to train their AI applications. But that's a really key point, because if they're training their AI applications, which then are informing business decisions, that data needs to be validated and it needs to be used to really correlate over past, present, and future to be able to inform the applications moving forward. So with AI, you get the cognitive workflow that brings in machine learning, automation, and that then feeds into operational processes so that each of these devices can start to learn and become self-aware. And then the sensors themselves end up providing a lot more intelligence. So this is probably the most basic of the connections that we're going to talk about today. No pun intended with the connections piece. But I think that really the idea is that with AI informing the IoT data, or vice versa, the IoT data informing the AI rather, it's going to lead to faster, more informed decisions for businesses. So when I was working on this presentation, this article or blog rather on LinkedIn really jumped out at me, and it was something written by our CTO of IBM Automation, Jerry Cuomo. And he didn't do this design, a graphic designer, Sean Lynch did, so all credit goes to him. But there's a couple of these visualizations I've included today to talk about piecing these things together, as I'm very much a visual learner. So I'll start with just the connection between IoT, AI, and machine learning as displayed here. We have a self-driving car, most likely a Tesla Model 3, and initially we are looking at the discovery process. So using the IoT sensor and the radar sensor, the car is discovering how close the other vehicles are to the car, and there's a tolerance threshold that is programmed into the car so that if it gets past a certain, or if it gets too close to a car, then it's going to have to make this decision and act accordingly. So with the machine learning, the car can sense whether or not the other cars are close in combination with the IoT sensor. And at the same time, that AI is helping to make that decision and then act upon it. So if the car notices that another car is too close, then it might either slow down or change lanes. All of this is happening in a continuous loop. It's taking the sensor data, processing it, and then the car is responding accordingly. So this in one little nutshell is just an example of how these technologies are all at play in a millisecond of time. So as I said, I'm going to break down each of the technologies we're talking about today to their most basic definition in the context of this conversation. So for today's conversation, edge computing is where the computational work's being performed close to where the data is being created and the actions are being taken. So just like we saw with the automated vehicle, that data is being processed at the edge because it's happening in the car at the time that the action's being taken, which is driving. So someone once told me that edge devices put the T in IoT, and so they are the things that are the data is being processed in at the edge. And so when you have these cars or even like an Apple Watch, really just anything that's processing data in real time at that location, that's the edge device, and that's really the thing that is making up the Internet of Things. So by applying AI and machine learning, it can analyze the data at the edge and help the applications make decisions and react faster. But in order for this to be possible, that's where 5G comes in. So because this edge computing is occurring in real time, in order to get that data to and from the device, it requires that ultra fast connectivity through 5G. And more specifically, to kind of put a number to this, IBM research found that moving IoT workloads to the edge can reduce latency to 10 to 20 milliseconds. And I'll give a more specific example in just a second related to cell towers. But this kind of just pieces together and bridges the gap between AI and edge. And now we're connecting that moving forward to 5G. So we talked a little bit about the autonomous vehicle, but then looking at a higher level at connected traffic, it really comes down to the dramatic cut in latency from 5G that makes these use cases possible. There's a ton of compute power that's needed at the edge in order to make things like collision avoidance and advanced traffic warnings possible. So you're taking this sensor-driven edge-based computing that's being processed via 5G in order to provide performance, security, bandwidth that's necessary in order for this connected traffic to become a reality. And it's all comes down to the real-time algorithm processing here. So you'll probably get sick of hearing me reference this piece of autonomous vehicles, but I really think it is the best use case to pull these pieces together. So we touched a little bit on 5G, but to dig a little bit deeper, I thought that this definition was really interesting, being that 5G is the interaction between two forces, the highly reliable high bandwidth, and then the spread of the available compute power throughout the network. So between the two, that's what gives the benefit to really the edge computing devices or IoT in general. So when you have this greater bandwidth, you're allowing more data to be sent during the same amount of time. So you can really help demanding payloads like video, and they can communicate with increased capacity, and that makes using things like video sensors, video data streaming a lot more feasible and a lot quicker. So you can use drones, robotic inspection, things like that. We'll touch on that use case more in a minute. But it's just enabling these devices to be that much more beneficial to corporations in different processes, depending on what industry they're in. I feel like if anyone was playing a drinking game, not this early in the morning, but you could really, the number of times that I talk about latency in this presentation is something that probably is a little bit of overkill, but it truly is the reason why the multi-access edge compute can then be possible. So it's the combination of that bandwidth and the lower latency that gives applications the ability to leverage edge computing. To put numbers to it, once again, you have the average latency of 4G connections being 50 to 100 milliseconds, and then the latency of a 5G connection going down to just 10 or less. From research, they found that 5G reduces device to cell tower latency, so this is a specific application, to around 4 milliseconds compared to 9 milliseconds for 4G. And although that 5 millisecond difference doesn't seem to be that big of a deal, it really is when you consider the mass amount of devices and the mass amount of data that's needing to be processed. So we look now, we've covered a bit about AI, we've covered a bit about edge and how it's related to 5G. Now digging more into how 5G is related specifically to IoT. When you look at the increased spectrum that becomes available with 5G and the overall bandwidth, it means that more devices can connect at one time and they have faster data throughput. So through my research, it's really found that with private 5G networks, they're most valuable when they're used for the transmission of large amounts of data coming from all these devices, in environments with a high density of connections. So think about a stadium with everyone being on their 5G smartphone, and also all of the different, connections within the stadium itself, and then where significant levels of data are generated. And that's a given when you have this high density of connections. So take the real-time data transmission and take the high connection densities, and with 5G, you're able to achieve the level of autonomous operations that businesses are striving for because of the edge computing that's enabled by 5G and the data that's coming from the IoT devices. So when you net it all down as to what's the benefit for an enterprise, it's that they have reduced operational spend because of this efficiency gain that's coming from 5G. So looking one level deeper, it's not just that the computing power of the network is the only benefit, it's that the IoT devices can get smarter and more powerful because of that compute. And in my months of experience in the telco space, which granted I know that many experts and some of you probably in the room or online have been in the space for probably longer than I've been alive. And so I know that I still have a lot to learn, but from the few conversations that I've been a part of, it's very evident that the telcos are redesigning their networks to have this dynamic and powerful compute environment to be able to allow for the uptake of IoT applications that incorporate edge. And so some of the use cases that I'll dig into deeper in a minute are remote monitoring, visual inspection, and then really just autonomous operations in large-scale remote environments like mines, like connected vehicles, like the stadiums that we mentioned, really any place where there's high density of connections. Didn't want to get too deep into 5G. Like I said, I'm still a student myself, but one thing that I think is especially relevant, getting a little more specific, is around network slicing. And I think that this visual does a really good job of explaining the benefit of network slicing, which is really the use of network virtualization to divide single network connections into multiple distinct connections that provide different amounts of resources to different types of traffic. So when you look here at machine to machine, there's the massive IoT slice, and that's often used in retail, shipping, manufacturing. But then you have the reliable low latency, which is on the mission critical IoT slice. So it breaks up the compute power needed and the resources needed into individual sections in order to really create that lane to help the data get to and from the device as quickly as possible. Once again, mentioning that lower latency and just the speed of 5G that enables this network slicing to be as beneficial as possible. And this process is a lot slower and less flexible with 4G. So we'll see the benefit here and a lot of use cases developing because of this 5G network slicing capability. So to put it into context, it's great to understand how the pieces fit together, but who's actually doing something with it. So IBM and Verizon back in July of this past year announced a collaboration that's really just around everything I've been talking about today. So we're leveraging IBM's AI-driven IoT solution, which is Maximo Asset Monitor, assuming that many of you have either heard about that or may have even worked with it before, since it's been in the IoT space for quite some time, and then looking at Verizon's wireless networks. So the 5G commercials that we hear every time we're watching anything on TV. I'm not sure if there's any red hatters on. I know there was mention of some of them being invited, but have to give a shout out to the fact that this Maximo Asset Monitor runs on Red Hat OpenShift, and that's our Kubernetes management platform that allows you to deploy workloads across different environments. So that's key here. And then Edge Application Manager is another solution, one that I work with, and that's going to be pulled into certain use cases because it gives the customer the flexibility to manage the IoT edge workloads at scale. So with the combination of Maximo plus Edge Application Manager running on Red Hat OpenShift, that's really how Verizon and IBM are looking to go to market. And the first solution that they're focusing on, or that we're focusing on rather, is to help industrial companies detect, diagnose, and then fix problems in those critical assets before they become an unmanageable risk. So really proactive operations, and we'll dive more into the use cases in just a second. The first one being remote inspection. I mentioned drones earlier. Sending technicians to sites where there's remote equipment or difficult to access equipment can be really cost and resource intensive. So when you take 5G and IoT and apply it in that scenario, you can use drones, remote cameras to really capture the images, video, any other sensor data, and that gets processed by AI in the cloud for that automated problem detection. So when you think about bridges, tunnels, highways, railways, especially in remote locations, you have this civil infrastructure solution that takes the data from the IoT sensors and the drones and everything that's gathered at the site, and it merges it with an analytical model that's industry specific to help identify and measure the impact of the damage, whether that's cracks or stress or vibrations, whatever might be causing that damage, you can really see it, whether that be through the video or the images. And these aerial inspections can be done not just to structures, but also to utility wires, gas pipelines. And the idea here is to catch the problem before it becomes a complete disaster, without having to send anyone to the site itself. So next, this use case is similar, but slightly different. It's visual inspection, and this is more specific to manufacturing. So low latency, just kidding, a 5G can enable AI-powered visual inspection at the product level. So in an assembly line, production line, it can spot equipment defects, and those can be remedied in real time rather than being identified after the fact, thus preventing recalls and bigger issues down the line. This is really just around product quality, and then it's when the defect is spotted, it's analyzed by AI and then processed at the edge. So that's how this whole real-time reaction and preventative maintenance can occur. 5G makes it possible for these manufacturing factories to have these wireless sensors and this equipment that really prevents the need for the extensive wiring or the local IT equipment that gets expensive and timely to manage and maintain. Last but not least, and this is kind of a given, but connecting that manufacturing equipment via the cloud really helps maximize uptime and reduces maintenance costs because things are done more efficiently. So this is kind of a, I guess, futuristic use case, or at least the way that I see it, with AI and augmented reality for technicians. And using 5G and edge, the bandwidth, the workload management, it really gives technicians the ability to leverage AR and receive that remote guidance. So it's almost like their super high-tech phone a friend option, if you will. We have a product specifically called IBM Assist that's meant to take an AI advisor and bidirectional AR-based collaboration and give technicians the next best action. So they know, here's the issue I'm experiencing. How can I quickly remedy this problem, whether it's from enterprise knowledge or just a remote expert that truly is phoning in a friend. They're able to resolve these issues more quickly and leverage that bandwidth and workload management that makes this all possible. This picture of the stadium makes me a bit jealous. I wish that I could be in that type of scenario. I'm sure we all do right now, but hopefully with the vaccine and everything, we'll get back to that soon. And when we do, 5G is going to be a factor because it's going to give connectivity, not just of the sensors in our buildings and our stadiums and airports, whatever it might be, the easier connectivity, but it's going to drive energy efficiency, occupancy management, and improve the visitor experience. Because when you're in a crowded place and you're trying to refresh an app on your phone and it's taking forever, 5G is going to make that easier to more quickly download and process applications. So this is a pretty obvious use case, but I think it's one that is worth mentioning regardless. Connected vehicles are back. So I think I just wanted to dig in, like I said, to this use case the most because it really does pull in each and every aspect of what we're talking about. Autonomous cars being able to collect more than 1 terabyte of data per day really highlights the need for 5G, edge, AI, all these pieces. Once again, latency brings more opportunities for bidirectional communication. So pretty much one car, if it is further ahead on the road, it could send notifications to nearby vehicles that would then expand kind of the range that any one vehicle can see. So if I'm X amount ahead of a different car and I notice that there's an obstacle in the road, the cars can communicate with each other using IoT, leveraging the low latency of 5G, and be able to know, okay, I'm going to change lanes in advance because there's an obstacle coming up before the driver or the car itself would even be in range of its radar detecting that. So this is especially important as there becomes a greater amount of connected vehicles because the aggregate data can extend the reach of any one individual car's sensors. And it's really making it safer and just more efficient to drive in an autonomous vehicle. So when we have agriculture, this is another one where it kind of is pretty self-explanatory, but we're leveraging drones once again that can go over the crops and identify different growth rates, pest incidents, and then farmers can use this data and information to target the specific areas that they need to tend to their crops and act accordingly. So really just speeding up the time to value for that information and making it more actionable for farmers and just showing that these use cases span multiple industries. Last but not least, we have shipping and logistics, and I'll explain a bit more about this once we get into the blockchain piece, which is coming up. It's really just at the level of the shipping container and even the pallet level that these shipments and shipping containers can be tracked and monitored. And this is especially important with how much product we get from overseas these days. So it gives more predictability to the supply chain, to things like inventory. And when you're looking at the pallet level, by leveraging the IoT sensors and 5G and edge, you're able to get things like temperature, humidity, when was the container last opened, where is it located at this moment in time. And so this use case is further enhanced by blockchain, and I'll explain a little bit how. But first, what is blockchain? So It was a really big struggle to come up with one definition to put on this slide. And so once again, for the sake of today's conversation, blockchain is that tamper-resistant audit log that provides provenance of shared transactions, which in this case is going to be based on IoT data and even the devices themselves. So I'll explain a bit more here, but the best analogy that I've always given for blockchain is it's kind of like a Google Doc. So when you have a Google Doc and you invite others in, you can track their changes and you can see who edited what, when they edited it, and then once it's in there and it's saved, it can't be tampered with because you can lock the file. So others that aren't invited to the file aren't allowed in, and those that are invited to the file have that shared visibility. So that's just one kind of piece. And then for the tamper resistant, or sometimes people call it immutability, I like to think of that as taking a test in pen. So it's not that things can't be changed, it's that all the changes are tracked and you can go back and see what change was made. So on a test, if you switched your answer from A to B, you could tell that you initially circled A, crossed it out, and then ended up with B. So that's similar to the blockchain. It's not that if there is an error or data is on the blockchain that's inaccurate, it can be corrected, but it's never erased. So like I said, I'll cut myself off there just to avoid going too far down a rabbit hole. But when we look at blockchain, just doing a quick time check, when we look at blockchain in combination with IoT, you think about the autonomously executing transactions that are made possible by a smart contract. So a smart contract is really just an if-then statement embedded into code. So if XYZ terms are met, then execute said transaction. And so it takes out the intermediaries that slow down a transaction and allows for the things in the Internet of Things to transact with each other without a human needing to be involved. I think on a couple slides, I'll show another visual that brings back Jerry Cuomo's graphic and how this is really made possible without human intervention, that these things can interact with each other because of something like a smart contract. Each transaction, because it's stored on the blockchain, can be verified. So we're not just trusting that these transactions are happening. We're able to see them in near real time and also validate the participants. And we can enable the blockchain to provide that trust layer among network members. So even if it's not them interacting directly, if their devices are transacting, they get that level of visibility, and it can prevent disputes down the line, which are often costly and time consuming. Last but not least, with blockchain, you're able to give IoT devices an identity. So like I said, a pallet on a shipping container that has an identity from the RFID that can then be validated and verified throughout the life cycle. So as that pallet is scanned, all of the data associated with it is stored to the blockchain, and then people can reference that blockchain for that data and have trust in the transactions that are taking place. So to give more context, I wanted to talk about one of the use cases that I think is most helpful to understand the way that blockchain can benefit IoT, and that is our work that we did with Golden State Foods. They are the fresh hamburger patty provider to a variety of restaurant chains, and because they have fresh patties and not frozen, it's really important that they had this visibility and this validation coming from blockchain and IoT to basically prove freshness along their supply chain. So they could, with blockchain and IoT, stream data throughout the food journey from production all the way to being taken out of the refrigerator at a restaurant. And they can get that pallet level visibility of what's happening in the field. So not only are they connecting the different members of the supply chain from the manufacturer to the distribution center to the end customer, which in this case is the restaurant, but they're able to validate using the IoT sensor that that tight temperature zone has been maintained and say, yes, this beef is in fact fresh, and here's the data that can prove that. In the end, it helps not only with giving the visibility along the supply chain, but also reduces time spent on reconciliation, because if there was an error along that route, say that when it was on the distribution truck, that truck was pulled over for too long, the temperature in the truck got too high, and the food was spoiled, well, then they can pinpoint where in that supply chain process something went wrong. So they're able to not only do that, which can hold parties accountable, but they can optimize their inventory and prevent waste because of the real-time visibility that the blockchain and the IoT combined provide. So as I mentioned, this is something that I kind of wanted to use to connect all the dots and to really show how these pieces come together once you include the blockchain piece. So the earlier diagram was around AI, IoT, machine learning, and this pulls in blockchain too. So in this scenario, you have someone who wants to rent a car, and the company is Rent Now, and they're a touchless rental car service. So you get on your phone and you have this application. In the application, it asks you to scan your license, input your insurance, maybe just scan your insurance card, and then input credit card information. So that's kind of the discovery phase of gathering the necessary data, putting it into your device, and then you're able to have this autonomous rental contract, which is living on the blockchain, and it's essentially a smart contract, because if your license is valid, if your insurance policy is active and your credit card's active, then the contract can self-execute. Basically, your credit card would be charged, and you would get a text to your phone that would serve as the digital key. However, there's another important component. The car needs to be available in the first place. So leveraging IoT and GPS, you're able to see, okay, Sally is at this location in Dallas, Texas. Is the car that she wants available in this location? Yes. Okay, now that we've checked the boxes around the fact that she has a valid license, insurance, and she can pay for it, we'll send her the text. So there's no human involved. You're able to really pull together IoT, blockchain being the smart contract, and then you're able to validate all these different pieces of data using AI, and then send it straight to your phone so that you're able to drive away with this digital key, and all of this was executed without any human interaction. So this is kind of the end state, and I think it's important to note that this discovery and this acting and this decision making is all happening in a closed loop. So there's no human interference. The data is being validated by the technology and by the processes that are underlying this whole operation, if you will, and we're able to see the power and see the speed in which someone could rent a car without needing to do anything that involves going up to a counter, talking to a person, and signing all this paperwork. So I think that's kind of cool, just to imagine the desired end state and what all of these technologies look like in a realistic situation. So to connect all of the dots, and I know there's been a lot of them, I think the key points to take away from this presentation are that IoT data is used to train AI applications. So that's the connection between AI and IoT at its very most basic point. Then you have this IoT data being processed in near real time at the edge. This is only made possible by 5G, and all these devices can connect in the high density that they're in with faster throughput because of 5G. And then last but not least, as we just talked about, the IoT data can be shared and trusted using the blockchain, which then kind of pulls all the pieces together and fills any gaps that there might be in not being able to trust the data, or not being able to trust the different devices transacting with each other without human intervention. And the end state and the desired goal of corporations right now is to get to this point of autonomous operations. And so leveraging IoT data combined with AI, 5G, edge, and last but not least, blockchain, that's where these companies are going to be able to achieve this. And it's already happening with some of the use cases that I discussed earlier. And I'm really looking forward to seeing and hearing all of your input on where this might be starting to take shape in your industries or even in your businesses themselves. So I know I haven't been able to see questions in the chat because I've been screen sharing, but I will close out now so that I can see, and hopefully we can cover everything. But thanks for sticking with me through this. I know we covered a lot, and hopefully it was informative and you learned something new.
Go ahead with the question.
In your example of the touchless rental car, how does your system prevent fraud? For example, somebody mugs me, gets my wallet, has my driver's license, and insurance card for my car. They go in the rental car, commit a robbery, stuff like that. The data is going to still show that my license is valid, my insurance is valid. If someone's doing that, they commit fraud. How does that work?
So with the blockchain, there's such a thing as zero knowledge proofs, and I didn't want to dive into them too deeply today, but basically it's the validation that without having to input that data directly, you could validate that you do, like it would basically call out to your records so you could have a more secure application on the back end. So you're not dealing directly with the rental car system, the application and like that information that's already in your phone or that has already been scanned on a more secure application, it could get called out to. So I guess the way that I'm explaining it now is not very clear, but the security comes from the blockchain that's on the back end, and the fact that you could leverage zero knowledge proofs to be able to not necessarily have to scan your license or have to put your credit card into that app, but it's connected to a more secure application on the back end that's sitting on the blockchain. I see some questions coming in on the chat. What do you see as some of the challenges that companies encounter in deploying these solutions? Well, first and foremost, it's just a matter of trying to do too much at once. I think that companies, like I said, at least within the blockchain space, it was, oh, we want to do blockchain, but the question was really, are you set up for this to be possible? So do you have everything digitized? Do you have all the players at the table? Do you have these different pieces of the puzzle that are going to be necessary? So when you think about even what we're doing with Verizon, it requires a variety of solutions. So you need your IoT component, you need your 5G component, you need your edge solution, and they all need to be talking to each other. So it comes a lot with the back-end resources and making sure that all of that is sound, and then being able to build on what we're calling an automation platform and just plug and play with different applications. I think another piece, and this is more just from my experience in blockchain, is needing to have that consortium or that network effect. So if you don't have partners in your supply chain that are wanting the same things or that see the same benefits from these technologies, it makes it really hard to gain that shared investment. And so I think that it's really a matter of getting that sense of collaboration and that agreement established before embarking on these big projects, as opposed to one company starting it and then realizing that they don't have enough support from their ecosystem to really bring the whole thing to life. So I think that question is valid. It's something that I'm going to need to have more experience in the 5G and edge space to be able to speak to in that regard. But in the blockchain space, it was really about needing to get all your members on board before you get too far into the process, and having everyone agree upon what the incentive is and what the benefit is of the solution before just asking them to jump in and not having that validation and that commitment beforehand. Let's see, with network slicing, does that improve security on the network, maximizing the 5G capabilities and IoT device trust? So I'm not sure as far as whether it improves the security, if I'm being completely honest. I think what it does is it improves the speed and it improves the reliability of getting that data to and from the IoT device, because there's allocated resources for each network slice. I would assume that you could increase the level of security based on the slice. So like I said, there was that mission critical slice, so that's going to have the most security embedded into the process, but I think that there's probably others in the room and online that could speak more to that than I can, if I'm being completely honest. So possible solution is AI facial recognition in rental car to match up with picture on the driver's license. Yes, that is one possibility. Thanks, John. I think when you have something, if you're using a mobile app and your phone already has to do that facial recognition to unlock your phone, then yeah, you could use that to cross-reference your license without having to put your license directly into the application. Other questions, or even if others have experience of seeing these applications tied together in their own businesses or industries, I'd be curious to hear about different use cases as well.
Do you have any ideas? Ashwan, you guys are involved in the edge a lot.
Yeah.
How do you see what IBM is doing with the edge and 5G, and what Talbot is doing to enable edge processing?
Yeah, so the stuff is very interesting from our perspective as well. We're trying to build a consumable and composable edge infrastructure, primarily for IoT and industrial IoTs. We're actually building a software platform. We go by smart computing. And in that platform, we're offering services like similar to Amazon Web Services, but for IoTs in general. And with capabilities like blockchain or ledger, as well as compute, database storage, key value database, and there's a few others. And so all of this can be consumed on the internet. We're trying to make it highly composable so that unlike other providers that use the Kubernetes type technologies for centralized approaches, we're at more like a decentralized approach because it's part of the edge. And we're trying to make that very easy for the developer community to utilize. To make edge computing something that's very easy to implement for IoT devices.
How do you see that playing with IBM? Is what you do a complement or in place of what IBM is doing?
I would say it's what we're doing is aligns well with what they're doing, but we're really for the developer community, right? So if IoT and blockchain, all these technologies are kind of applications are being developed by IBM, they can utilize our platform. The developer community can utilize our platform to realize all these use cases. So we're at we're like a software layer, right? We're at a software layer on top of the edge computing infrastructure. So we're closer to the IT, basically all the servers and the IoTs. We're agnostic with respect to the hardware itself. So any kind of a software that you develop can be highly portable among all the variety of hardware products that are out there. But whatever you build using either Go, C, C++, any of these myriad of programming languages, they will, through our platform, they will compile to WebAssembly. So, and that WebAssembly can be easily ported among all the different hardware devices. And so, our platform, I believe, would be a key solution in the edge infrastructure space.
So Paige, in IBM's development of these solutions, do y'all look at companies like Talbot, and of course you're working with Verizon to create these solutions?
Yeah, so I think, a lot of our telco work is done through partnerships with companies of all different sizes. I think that as these solutions get built out more, there'll definitely be more opportunity for collaboration. It starts kind of at this bigger level with the likes of Verizon and Samsung, but then we're pulling in different applications, and I am envisioning more of a edge application marketplace. We got to that point with blockchain, and I think the edge will be the same, where you can plug and play different layers that sit on the edge computing infrastructure based on what your use case is. So I definitely see potential. I'm not aware of any specific collaborations at this point in time, but I think that it's really an area for growth and opportunity there.
Be the person for our community to contact, to kind of direct them if there is things they believe they could bring to you and add value to the IBM solutions?
Yeah, absolutely. And I think, like, as of right now, our telco cloud specifically, we have about 35 ecosystem members, but I know that that's growing. And so that was just announced in November. And so it's like, even if your company is working with one of those ecosystem members, then I can definitely get you connected into the overall conversation. And even if I'm not the right person, I think that it's definitely worth reaching out, because I'm happy to connect you with anyone that would be the right person.
Appreciate that. Sammy, is there anything that you wanted to add to Ashwan's comments?
Sure, yeah, I mean.
Sammy, introduce yourself.
Yeah, Sammy Fudel, I'm the founder and CEO of Talbyte. So I think what I said is pretty descriptive. Yeah, I mean, we're not building an infrastructure. We're building a platform on top of an existing infrastructure that's at the edge and growing exponentially. So whatever, like everything you said makes sense. What IBM is building. The dark side of that is that all those products that you guys are building are hard to be consumed by developers, and this is where we come into place to make them consumable and composable. So imagine telling a developer to handle Kubernetes at the edge with tens of thousands of containers and building like different flavors of these containers for different architectures. That doesn't scale, and this is where we come into place. So, yeah.
All right, very good. So are there any other comments or questions that the group, the people here in the room would like to ask? Otherwise, Tom, anything you wanted to ask? You're good? All right, good. So, Paige, thank you very much for your presentation and going over all the different things that are going to get pulled in to create IoT solutions. Very interesting what's going to happen. We're in exponential times. In the next 5 or 10 years, we're not going to recognize the way we've done business in the past and the way the world operates. So hang on to your hats. IBM and all the different technologies that are coming online and being commercialized are going to change our world, hopefully in good, positive ways. And so thank you, Paige, for being sharing with us IBM's vision and what you guys are planning on doing. So with that, Gary Ramsey, if you would take over the online, and Paige, hope you can stay for a few minutes, but I know you got to run to the airport. And Gary will then lead the online group and do a question and answer session, a roundtable, and kind of encourage sharing of information to people that couldn't be here today. So you guys online, thanks for coming. We'll talk to y'all later. Everybody in the room, any other comments, any others? Thank you. Yeah, let's give Paige a hand. Take it away, Gary.
All right, fantastic. So what I want to do is just go through the guys that are still here left online. So what I'd like for you guys to do is to unmute yourselves. I'll call out your name, and if you could just unmute and introduce yourself. So Marie, it looks like you've already done that. Why don't you go ahead and introduce yourself and just tell us a little bit possibly about some of the exciting projects you're working on right now.
Okay, my name is Maria Breckenridge, and I work for DFW Airport. I am in the innovation group, and we actually have done 3 design sessions in the last 6 months with IBM. So we are currently looking at how do we do 5G deployments in cargo, in the terminal, and we are specifically looking at how do we create an ecosystem of partners to deploy IoT networks? So that was my reason behind my question on network slicing, because I'd like to get off the public network and start using more of a private network that's architected and designed and customized for our partners. And that's me.
Paige, did you want to make any comments around that?
Yeah, I didn't know if I was going to talk over someone, so I was waiting a second, but that's awesome. I'm glad to hear that you guys are already well into that process. I think that it kind of, a few of the things that you said, and that makes sense on the network slicing question. And I want to dig into that deeper and go back to the 5G experts on our broader team and get more information on that from you. So, or for you rather, so I can send it to you via LinkedIn or whatever's easiest. Because I think that there's a few different similarities in what you guys are working on and what's coming down the line. So I can get you more information, and thanks again for joining today, and hopefully all those projects are successful.
Agreed. Thanks, Paige. I would love that.
Okay, EE, we got your video. You want to go ahead and introduce yourself and tell us what you're working on?
Hi, this is Yi Wang. I'm with Machine Chat, a company that's focused on IoT data management software. I think it looks like my video is acting sort of slow. Can you guys hear me?
We can hear you, yes.
Okay.
Continue.
So our focus is actually on-prem. Part of the problem that we solve is that many companies, when they do IoT deployments, it's great to be able to connect to applications like
EE, I think we've lost your audio also. Can you hear me? We lost her completely. Okay, well, hopefully she'll get back on here. John, can you go ahead and unmute yourself, introduce yourself, and tell us about what projects you're working on right now?
Hey, good morning, everyone. I'm John Hamer. I'm a center engineer with Verizon Business and managing projects for network expansion, which will enable all of the 5Gs and AI initiatives that Paige has been talking about. So this is really exciting for me to learn more about how what we're building on our side is actually being utilized by our customers. Most all of my projects, actually all of my projects are in Southern California. So we're doing quite a bit of an expansion in that area. So that's what I'm interested in, all things AI and blockchain. I guess still am a charter member of the Dallas Blockchain Alliance when that still existed. So I've been involved in that and interested in that for some time. So thanks.
Excellent. Solomon, you want to go ahead and unmute yourself and tell us about what you're working on?
Sure. I'm Solomon Israel. I'm the CTO for a company called SkyMax Network. We are actually a greenfield telecom provider looking to put 5G telecommunication networks into sub-Saharan Africa. So that's basically what we are and what we're doing. And it was interesting to hear the use cases that Paige was going through.
Excellent. Let's see if we can get EE to come back in. It looks like she's come in. You want to go ahead and continue where you dropped off?
Sure. So I don't know where I dropped off, but Machine Chat is a California base. We're based in Silicon Valley. And we do a ready-to-use IoT software solution that allows, that's edge-based, that allows people to get the IoT data without changing any native protocols or doing any customization in the firmware of any sensor or device off of those devices. And what I say is that we get the right data at the right time to the right applications. So it's a single software binary that's about 19 megabytes and sits just underneath the network layer on-prem.
Outstanding. We've got a new person pulling in here. It looks like May. Would you like to unmute yourself and tell us a little bit about what you're working on?
Hello.
There you go. Yes, go ahead and introduce yourself, May.
I was talking to myself for a little while. Yes, I'm a PhD student. I'm not in the industry. I mean, not in the blockchain industry, but I'm in the IT industry. Working on my dissertation and still try to design what kind of topic to work on, but mostly about blockchain and IoT, this area, and also business value of blockchain and IoT. So yeah, I'm trying to get some idea about which direction to go, and also mostly wanted to get more like the direction of where to get the data, because that's the most important part of a dissertation.
All right. Well, let's hold that off and we'll ask that question here. I've got one more person we want to get in and have them introduce themselves. Hopefully I'm not going to butcher your name here, but Shabazz, you want to unmute yourself and correctly pronounce your name? I'm sure I butchered it.
Can you hear me right now?
I can hear you.
Okay, good. Thank you. I appreciate it. As Romanian, actually, I'm right now in process of changing position. Last position was at Verizon business unit, and I had some 5G experience in the past while I was at the Ericsson doing the 5G trial at the Verizon to validate the wireless broadband services also. And of course, I had other IoT application for a smart city, for City of Dallas, also during my time at Ericsson. So right now I'm in the transition mode to get the new positions.
Excellent.
Yeah.
Kay, do you want to try it again? See if you can unmute yourself. Well, just do a quick introduction and anything that you want to tell us that you're working on at this point.
Oh yeah, I'd love to. Thank you. I am the founder of Sales Enablement Strategies. I have had a career of large strategic technical sales and decided to go out on my own to assist companies, even from conception to trying to figure out how to launch, what the customer base is, who they should target, price points, getting funding, helping with pitch decks, to help them get to profitability and those first valuable customers. And I'm excited to say there is a new company that I have had the opportunity to work with called Titan. And they are a profitable company already. There was a product developed cooperatively between U.S. and India. And it's a multi-language tie-in to allow the Microsoft Office platform that we all get with our Office accounts, and specifically for large enterprise, where they built kind of a front end that ties 365 and all of the features therein and Teams, along with SharePoint, because SharePoint has been historically very difficult to use. They built kind of the interface and front end to set up all the policies and procedures and make it easy. You don't have to have any programmers. They can take existing SharePoint services and help move those to the cloud without having to do a total rewrite. So, would love to visit with anybody that has any interest in that, or organizations that do use SharePoint. They've got, it's designed for very large companies, like I said, or medium to large companies. They've got customers such as WHO, World Health Organizations. They've got two of the largest pharmaceutical companies in India, the largest bank in Saudi Arabia. So it is a very quick, rapidly growing company. Like I said, it's already profitable, and I am privileged to have the opportunity to meet the CEO and work with the founders here at Hexa and get the opportunity to be the first one to represent the product in the U.S. So it's a great opportunity and appreciate it. If anyone wants any more information or would be willing to make introductions to potential customers.
Fantastic. Okay, well, we kind of left off with May. May, you'd had a question. You want to go ahead and ask that again. And Paige, if you might be able to chime in and see if we might be able to answer the question that May has at this point. May, you want to unmute yourself and go ahead and repose that question?
No, I did not raise my hand or anything. No, I don't have a question, but I do wanted to know, because when I am working on the research, I do wanted to know where can I find the research data to prove my, the topic is the business value of IoT on the blockchain. So yeah, if anybody can give me a pointer, that would be great.
Paige, do you have any resources?
So not that I'm aware of, I did look into it a bit, but most of our data isn't public, unfortunately, at least that I have access to. I'm not sure if others know of any online repositories where May might be able to find such data, but unfortunately from our projects, I think it's all kept pretty close to the customer.
Okay. Is anyone here online that might be able to provide any pointers?
Yeah, I guess the data is hard to find, because blockchain is an emerging technology, first of all, and then they don't have a lot of secondary data, So I guess my approach may be eventually need to do some interview or just on a conceptual level, like doing something.
Well, I
like
do
that.
know that there's an IEEE group that does presentations every so often around blockchain. So if you want to possibly look in that direction, again, you probably hit the nail on the head when you said you just got to do some networking and find out who some of the experts are here locally that you could get some time in front of. Anyone else have any specific question? That,
just to add to that, Gary, I've actually done some work in the blockchain field with the universities, and I found them to be extremely well connected to some of the banks like Chase, Bank of America, where they are able to share some of that data from some of their projects. So UT Dallas, TCU, I did some work with them, and UT Arlington. They have centers where they're trying to build out blockchain, especially for trust and visibility into the entire token and digital ID systems. So that may be one area, May, that you want to reach out to.
Okay, sounds good. Can I have your email address?
Here, I'll put it in the chat if you wish.
Okay, yeah, sure.
Yeah, and I would say, I would kind of second what you're saying there. I'm a UTA grad, computer science engineering, and you might want to just reach out to some of the professors there at the universities. Also, I do believe that University of Texas Dallas, UTD,
Okay.
has some great talent there also. So, yeah, I would just reach out to the professors and see if they'll help you out. It's great.
Okay.
Anyone else have something that either a question or would like to ask the group for some additional help?
So I'd like to ask some help, Gary, if possible. I am designing a POC for the cargo and logistics sites at DFW Airport. We're specifically, for obvious reasons, looking at perishables. So how do we put a certificate, a token, some way to actually validate the journey, especially because you guys probably know that we're getting vaccines. So I know we're a little late to the game, but better late than never to design some of these POCs. But I am looking for some resources or for some experts in this field.
Okay, fantastic. Anyone else have an ask?
I guess I'm your only needy person this morning, Gary.
I we're all needy. It's just a matter of whether we're going to admit it or not. Yes, could I also ask everyone who's still online to go ahead and share your contact information, what you feel comfortable with, either cell phone or email address. That way we can keep in contact with each other. And again, what we're doing with this after the meeting is really just trying to help bring together the Dallas-Fort Worth, North Texas, let's just say world community ecosystem around IoT. And of course, the IoT is not just, the Internet of Things, but as we learned today, there's a lot of different elements and pieces that really get added onto that. And quite frankly, I kind of look at IoT as really the IT industry in general, because IoT touches pretty much every aspect of the IT industry. As we learned today, we've got elements of blockchain, we have elements of AI, because there's no way we start adding in billions and billions of devices that we as humans can keep track of that. So we're going to have some kind of a mechanism to be able to manage all these devices that are hanging off the internet. So that's what this group is all about, because we all bring expertise in IT, IoT, and of course all the various different pieces and elements of that, whether that's hardware, software, backhaul, communications, whatever that happens to be. So what we're trying to do with this group is really build a community here in the Dallas-Fort Worth area, where people can build trust relationships with other organizations and get to know people. And that's what this is all about. So for those that aren't able to physically make it here to the Hexa, beautiful facility here in North Richardson, and we're looking at using this forum to facilitate that. Thank you folks for joining us. Bye-bye.